Good morning. My name is Sabrina Metzger, and I'm presenting you high-resolution rate maps of Central Asia, that is, the Greater Pamir area and the Tajik Basin in particular. The Pamir is part of the India-Asian collision zone and is pushed northward to Eurasia, while at the same time collapsing west into the Tajik Basin. We used automatically pre-processed Sentinel-1 interferograms of the InSAR initiative and calculated individual rate maps of 13 ascending and descending frames using the LixBus small baseline time series analysis. The interferometric networks that passed our quality threshold, they were up to 5 years long. However, sometimes they contain significant data gaps, which is for many reasons. Either the archive was not fully available, or the data were highly decorrelated due to precipitation and high topography, which caused a lot of unwrapping errors. Since we were interested in the interseismic rates, we avoided data following directly the magnitude 7 SARS earthquake that ruptured the central Pamir in 2015. That was a magnitude 7 event. The resulting rate maps in line of sight exhibit highest uncertainties in isolated valleys, or also at places with many unwrapping problems. We also identified a phase bias by summing up all closed loop interferogram triplets of one frame. This bias is a combined effect of soil moisture changes, multilooking, and actual groundwater removal. In our tectonic interpretation later on, we will ignore these regions. We then tied the rate maps to a stable European reference frame by fitting them to the regional GNSS rates, so GPS rates. At the same time, we minimized along track frame overlaps. In a second step, we decomposed the line of sight rates into east and up by constraining the north with the interpolated GNSS data. The resulting rate maps, they show in great detail how the Tajik Basin accommodates east-west shortening due to the westward collapse of the Pamir. So this is a zoom into this east-west shortening in the Tajik Basin. The major part of this shortening is accommodated by the Babatak backthrust and the Iliac fault over here. We also observe extremely high westward and uplift motion in the vicinity of the Darvas fault. We also see spectacular salt tectonics at the Hoja Mumin salt fountain, and we can even resolve a magnitude 5 thrust event on the Afghan platform in space and time, where we see a displacement of a few centimeters only. When we look at rate profiles, we then can connect sharp rate changes to geometrical structures in the subsurface, which are derived from mapping and ground penetrating methods. Unfortunately, our rate maps are most problematic in the highly active central and western Pamir. But we clearly see how the active northern front of the Pamir, that has a significant textural component, backsteps further towards the south. We also see an increased subsidence and east motion in the vicinity of the Hindu Kush slab breakoff that is marked here with this purple seismicity. Thank you for your attention.